Hi guys, my name is Joshua from Motivao Online Instructors. Today we're going to start with the 1998 Harvard-MIT Math Tournament. Question 1 states, Farmer Tim is lost in the densely forested Cartesian plain. Starting from the origin, he walks a sinusoidal path in search of home. That is, after t minutes, he's at position t, sine of t. 5 minutes after he sets out, Alex enters the forest at the origin and sets out in search of Tim. He walks in such a way that after he has been in the forest for m minutes, his position is m, cosine of t. Question. What is the greatest distance between Alex and Farmer Tim while they are walking in this path? Okay, so let's write some information. Tim's position is what? It's t sine of t. Alex's position it's m cosine of t. Now, what's the relationship between m and t? Well, it says that 5 minutes after he sets out. So how do we express that mathematically? Well, m plus 5 equals t. Or t minus 5 equals m. Okay, now that we know that, we can plug in that variable into m. So Alex's position becomes t minus 5, cosine of t. Now it says, what is the greatest distance? Well, clearly we need to use the distance formula. So d for distance equals what? The square root of the t components, which would be t minus 5 squared plus the y component, which would be sine of t minus cosine of t squared. Let's close this up. Now, this simplifies this to what? Well, t minus t is 0, right? So we have 25 squared, which is 25, plus sine of t minus cosine of t squared. Now that we have our distance in terms of t, we take the derivative of d, n equal to 0 to find the maximum. So the derivative of t, I'm going to do a little manipulation just to make it simpler. I'm going to square both sides. So we have d squared equals 25 plus sine of t minus cosine of t squared. Now, if we take the derivative in both sides, in the left, by implicit differentiation, we get 2d times d of dt equals what? Well, the derivative of 25 is 0. The derivative of this, well, using chain rule, is 2 sine of t minus cosine of t times the derivative of the inside. Well, the derivative of sine is cosine minus the derivative of cosine is minus sine, so the negative with the negative becomes positive, and we have positive sine of t. Now we want to isolate dt. 2 cancels with this 2. Once we divide by d, well, if we divide by d, well, what's d? Well, d is the distance, right? So it will be the square root of 25 plus sine of t minus cosine of t squared. Now that we have our derivative, we want to equal that to 0. So if we equal to 0, we have sine of t minus cosine of t, cosine of t plus sine of t. Since we have the multiplication, we equal each part to 0. So 0 is sine of t minus cosine of t, or 0 equals cosine of t plus sine of t. Now, if you can see, we have sine of t and cosine of t. So let's relate those together. We have that cosine of t equals sine of t, or minus cosine of t equals sine of t. If we divide by cosine on both sides, we get 1 equals sine of t over cosine of t, or minus 1 equals sine of t divided by cosine of t. Now, sine of t over cosine of t is what? It's tangent, right? So we have that 1 equals tangent of t, or minus 1 equals tangent of t. Now the question is, when is tangent equal to 1? Well, tangent is equal to 1 when t equals pi over 4, or 5 pi over 4. And the question will be, when is tangent equals to minus 1? Well, tangent is equal to minus 1 in 3 pi over 4, or 7 pi over 4. Now, where is the maximum and where is the minimum? Well, let's write our equation, our line equation for the derivative. And we set 0, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And we can just write it a little longer here, 2 pi. So let's choose values between 0 and pi over 4. Well, just 0. And where do we plug this value? In the derivative, right? So this is our derivative. If we plug in 0, we have that in the top. We have 0 minus 1, which is negative, times 1 plus 0, which is positive. So negative times positive equals negative. Now choose a value between pi over 4 and 3 pi over 4. Pi over 2. And plug it in the derivative. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. So that's positive. Cosine of 0 of pi over 2 is 0. Sine of pi over 2 is 1. So positive times positive gives us positive. Now a number between 3 pi over 4 and 5 pi over 4. Pi. Do the same thing. We insert in the derivative. Sine of pi is 0. Cosine of pi is minus 1. So negative times negative is positive. Now cosine of pi is negative 1 plus 0. So negative times positive equals negative. By symmetry, this is going to be positive, this is going to be negative. Now, in pi over 4 and 5 pi over 4, we have a minimum. In 3 pi over 4 and 7 pi over 4, we have our maximum. Now, since there's no interval in this relationship, it's going to be 3 pi over 4 plus every revolution. So, our maximum is at t equals 3 pi over 4 plus 2 pi k, for k in the whole numbers, integers. Now, we want our maximum distance. So we're going to plug in that t into our distance formula. Which is this one. So we have the d of 3 pi over 4 equals the square root of 25 plus sine of 3 pi over 4 minus cosine of 3 pi over 4, everything squared. So this is equal to the square root 25 plus sine of 3 pi over 4 is square root of 2 over 2 minus cosine of 3 pi over 4 is minus square root of 2 over 2. So minus times minus equals plus. So we have 25 plus square root of 2 over 2 plus square root over 2, square root of 2 over 2 is 2 times square root of 2 over 2. So the 2 cancels. So we have square root of 2 squared, which is just 2. So in the end, we just have the square root of 29, which is our answer. Thanks for watching, guys. This is Joshua from motivao. You can comment, you can go to our website, motivao.com, and I hope you enjoy.